hyperbola. We start with r is equal to 8 over 2 plus 3 cosine theta. I'm going to divide everything by 3. No, I'm not. I'm going to divide everything by 2. Because I need that first term in the denominator to be 1. So we'll have 1 plus 3 halves. It's okay to have a fraction down there. Plus cosine theta. So E is 3 halves, which is greater than 1, so I know I have a hyperbola. Alright, this fits the basic form of r is equal to e d over 1 plus e cosine theta. So the directrix, or one of my directrixes, is going to have the equation x is equal to d. So we find d. 4 is equal to e, which is 3 halves, times d. We're solving that for d, you get 8/3. So one of our directrix equations is going to be x is equal to 8/3. Alright, so let's start organizing what we know. And I tell you what, this is going to get kind of messy, so I'm going to snag one of my grids and make it as neat as I possibly can. Order, send to back. Okay, so I have a directrix at x equal 8/3, which is 2 1/3. So let me draw that line. It'd be about right there. We have a focus at the origin. Okay. So let's go about it this way. Let's let theta be equal to 0. If we do, r is equal to 8 over 2 plus 3 times 1. Cosine of 0 is 1. So r is equal to 8/5. So one of my vertices is going to be 0, 8/5. And 8/5 where is that? 8/5 is less than 8/3. 8/5 is about 1.6. So maybe this is our vertex right here. Call it V1, F1. Alright, since that is on the x-axis, then the rectangular coordinates for that vertex, polar coordinates are 0, 8/5. No, 8/5, 0, sorry. And that ends up being also the rectangular or Cartesian form of that vertex. Okay, letting theta be equal to pi, we get r is equal to 8 over 2 plus 3 times -1. Gets me an r value of -8. So the polar form is -8 pi. So the rectangular form for the second vertex is negative 8, 0. So our second vertex is 1, 2, 3, 4, 5, 6, 7, 8, right here. Okay, the distance between the two vertices would be 8 plus 8/5. Ooh, I did that wrong. I'm sorry. Back up. I knew something seemed strange. That's wrong. This is wrong. If the polar coordinates are negative 8 pi, then the rectangular coordinate, negative 8 pi, rotate to pi to get you here, then we got to count 8 units this direction. So 1, 2, 3, 4, 5, 6, 7, 8. This is our second vertex. So V2 is actually positive 8, 0. Okay, now the center point is going to be exactly halfway between those two vertices. So the distance 8 minus 8/5 is 6.4 units. Okay, so what I'm measuring here is this distance right there. It's 6.4. Half of that is 3.2. So if I go 8 minus 3.2, I'll have 4.8, which changed to a fraction is 24/5. So the center point is 24/5, 0. So 1, 2, 3, 4.8 would be about right there. There's our center. Okie dokie. From the center to the vertex is the length A. And that length is 16/5 of a unit. From the center to a focus is the length C, and that length is 24/5. So our second focus, which would, the first one we've got is 24/5 of the unit to the left of C. Now we want to measure 24/5 of a unit to the right of C. So think 24/5 plus 24/5 is 48/5. The second focus, point F2, is going to have coordinates 48/5, 0. So our point F2, that's 9.6. So 1, 2, 3, 4, 5, 6, 7, 8, 9.6 would be about right there. Almost off of where I've got room. Okay, so focus F2 is 48/5. Alright, we need the other directrix. The distance from a focus to the directrix, or actually you could measure from the center to the directrix, or you could measure from the vertex to the directrix. Whatever all these distances are going to be consistent when you measure in the other direction to the other directrix. I worked it by measuring from the focus we had to the directrix we had. Okay, that distance is 8/3 of a unit. That was easy for me because the equation of the directrix was at 8/3. So if our first directrix was 8/3 of the unit to the right of F1, our second directrix would be 8/3 of the unit to the left of F2. So 48/5 minus 8/5 no, 8/3. I knew that didn't look right. That ends up being 104/15 equals x for our second directrix. Alright, that's about 6.9, almost 7. So 1, 2, 3, 4, 5, 6, almost 7. I'm going to put it about right there. Okay, so that's the equation. X is equal to 104/15. Alright, if we're going to sketch this hyperbola, we need to know, I know that our box that we have to draw is going to go through the two vertices, so I kind of know where the vertical parts of the box are going to be, but I need to know how tall the box is, and for that I need b. In a hyperbola, b squared is c squared minus a squared. So we're looking at 24/5 squared minus 16/5 squared. We get 64/5. Taking the square root of that gives you 8 over the square root of 5, which is approximately 3.6 units. This tells me how tall our box is. So from the center point, what did I say that was? 3.6. I'm going to think about counting 1, 2, 3.6, 1, 2, 3.6 units. And now I'm going to draw in the box. And now I'm going to fix the box. Okay, the box allows me then to draw asymptotes, which I need to be able to sketch. So the asymptotes should go through the center and through the corners of the box. Alright, and so our hyperbola has to contain the vertex points and curve around the focus points. So we have a hyperbola that has branches that kind of curve around left and right, looking something like that.